Good morning, everyone. My name is Idika, and today I'm presenting our research on explainable artificial intelligence for credit risk assessment in microfinance conducted at Sri Venkateswara College of Engineering. Let me start with a simple question. Imagine you are a farmer in rural Tamil Nadu. You walk into a microfinance office and apply for a loan of 50,000 to buy seeds for the season. A few minutes later, a computer says rejected. No reason, no explanation, nothing. You walk away with no idea what went wrong or what you can do differently. This is the problem we set out to solve. Machine learning models are increasingly being used to automate credit decisions in microfinance. These models are powerful. They can spot the risk assessments that traditional methods miss. But they have one critical flaw. They are black boxes. Models like random forest, gradient boosting, and deep neural networks take in your data and give a yes or a no, but they do not tell you why. This is a serious issue on multiple levels. For borrowers, they cannot understand the rejection, appeal it, or improve their situation. For regulators, in the European Union, the GDPR already gives the people the right to an explanation for these automated decisions. The upcoming European Union Act classifies the credit scoring as high-risk AI and demands full transparency. Even India's RBI has begun mandating the responsible AI guidelines for banks. And for fairness, in India, over 190 million people still lack the access to formal banking. If automated systems reject them without any explanation, we are deepening that inequality and not solving it. We propose a complete end-to-end XAI pipeline, explainable artificial intelligence that combines two powerful tools, XGBoost and SHAP. XGBoost, one of the best performing gradient boosting classifiers for structured financial data. It builds the trees sequentially, each one correcting the errors of the last, with built-in regularization to prevent overfitting. And SHAP, which stands for Shapley Additive Explanation. SHAP comes from a cooperative game theory. It calculates how much each feature contributed to a particular prediction, not an approximation, but an exact mathematical grounded breakdown. Together, they give us a model that can make accurate decisions and explain every single one. We tested our framework on the Give Me Some Credit dataset, which has over 150 million real-world loan applications from Kaggle, widely used as a benchmark in credit risk research. The dataset has 11 features covering revolving credit utilization, age, income, debit ratio, number of late payments, dependence, and more. The target label is whether a borrower had serious payment delinquency, 90 or more days late, within 2 years. Now, real world financial data is messy. And this data set reflects that. So we have carefully built a pre-processing pipeline. Missing values, monthly income had nearly 90% missing data. So we used a KNN imputation with K equal to 5 to fill it intelligently. For dependence, we used a median imputation. Outliners, some debt ratio went into thousands. Clearly, those data entries are errors. We capped that values at 99th percentile using minorization. Class imbalance, only 6.68% of the borrowers in the dataset actually defaulted. That is a big imbalance. So we handled it using SMART, synthetic minority oversampling technique, which creates synthetic samples of the minority class. Critically, we applied SMART only inside cross-validation folds to prevent data leakage. For the XGBoost model, we ran a grid research with a 5-fold stratified cross-validation to find the best hyperparameters. Our final model used around 200 boosting rounds, a maximum tree depth of 6, a learning rate of 0.05, and a scale pause weight of 7 for further compensate for the class imbalance. For SHAP explanations, here is the intuition. Think of it like if 10 players on a team are going to win a prize together, then SHAP will calculate a fair share of credit for each player by looking at every possible team combination. Similarly, for each loan application, SHAP will tell exactly how much each feature, like credit utilization or late payment history, pushed the prediction towards approval or rejection. For tree-based models like XGBoost, we used a special version called TreeShap, which is computationally efficient. It can replace 1,000 applications in just 0.31 seconds on a standard CPU. This makes it production ready for real microfinance systems. A system generates two types of explanations: global global, which feature matters the most across all borrowers; local, for each individual, which specific factors lead to the particular decision. Now let us talk about the performance. We expected XGBoost SHAP against four baselines: logistic regression, decision tree, random forest, and LG light GBM. Our model achieved an accuracy of 91.2%, an AUC ROC of 0.943, and an F1 score of 0.889. To put that in a perspective, logistic regression scored an AUC ROC of 0.812. Our model beats it by over 13 percentage points. Even light GBM, the closest competitor, falls short by 3.5 percentage points in AUC ROC. The F1 score of 0.889 is particularly important. It tells us the model is genuinely catching high-risk borrowers and not just predicting low risk for everyone to game the accuracy metric. Now, for the SHAP feature important analysis, the top most influential features were revolving credit utilization, the most powerful predictor with a mean SHAP of 0.31 0.312. Borrowers using close to their full credit unit are significantly more likely default. Number of times are 90 days late, a SHAP of 0.287, past delinquencies are strong signals, and age SHAP of 0.21 with a negative direction. Old borrowers are seen as low risk because of their stable income. Now moving to a real example, let me show you in this action with a real rejected application from a test set. So this person is 34 years old. They are using 91% of their revolving credit, having been 90 days late twice, and has a debt ratio of 62%, earning 28,000 a month and have 3 dependents. The model gives them a risk score of 0.71, well above the rejection threshold of 0.50. But here is what our system does differently. Instead of just saying rejected, it generates this explanation. Your credit utilization of 91% is the biggest risk factor. Reducing it below 30% could lower your risk score by 18 to 22%. Your 2 instances of 90-day late payment are also a major negative factor. We recommend maintaining a clean payment record for 12 consecutive months before reapplying. This is actionable, that is empowering. The borrower now knows exactly what to fix and has a realistic path to approval. A common assumption in machine learning is that accuracy and explainability trade off against each other, that you have to sacrifice one to get the other. Our results directly challenge that. XGBoost SHAP is both the most accurate and the most explainable model in our comparison. We also acknowledge important limitations and future directions. Fairness. Age being a top feature could disadvantage young first-time borrowers, even if they are credit-worthy. Income could indirectly reflect geographic or social background. Future versions must include fairness metrics like demographic parity and equalized odds, and we plan to test adversarial debiasing techniques. Indian context. Our data set is US based, so to deploy this in Indian microfinance, we would incorporate alternative data like mobile payment histories, utility payments, and agricultural income patterns, which better capture the informal economy here. Multilingual reports. We plan to generate applicant reports in Tamil, Hindi, Telugu, and Kannada to make this accessible to rural borrowers. Conclusion. To summarize, we built an XAI framework that achieves 91.2% accuracy and 0.943 AUC ROC, outperforming all the baseline models, explains every decision both at the global model level and for each individual borrower, generates plain language, actionable reports that the borrowers and the loan officers can actually use, runs efficiently enough for real-world deployment in microfinance institutions. We believe explainable AI is not just a technical feature, It is a matter of fairness and trust. In a country where millions of people are still excluded from formal credit, giving borrowers an explanation is giving them a chance. Thank you.